Should I use this or no, just my mic here? Okay. So I'm embarrassed to say when I gladly accepted the invitation to come talk here, I thought it was going to be a very small, like very interactive technical discussion. And I thought, well, I don't have anything impressive to show yet related to MCP, but we're working on a lot of MCP related experiments. And I would love to come and I have a few discussion topics that I really would love to bring to this group of MCP devs. And so here I am with discussion topics and a few very technical semi-demos as opposed to anything flashy and impressive. So hopefully that's okay. So the call to action is if anything I mention is interesting to you as a topic or as a puzzle to solve, please find me after and help me solve the puzzle. That's really what it is. So, okay, so I'm the co-founder of a company called Dagger.io, and we made a build engine, and then we made it generalizable and programmable to the point that it could run all sorts of workflows, not just build workflows, but all the workflows attached to the build, testing, deployments, and all the random stuff that are attached to software delivery, right? And we built it from first principles. First, we built it from containers, surprise. And so we built our own sort of embedded container runtime, but designed not for random container execution, designed for builds, right? Designed specifically for DAGs. So you run a container, and then you get a snapshot of the container state. It's ephemeral. From there, you can chain more operations. If you're familiar with BuildKit, which is the underlying technology for Docker build. Well, that's stuff we were involved in building back at Docker. That's kind of the hidden gem in the Docker stack. There's so much more that you can build on top of that because it's really a general purpose DAG engine. Or it can be if it's freed from the Docker file syntax. That's just too limiting. So we took the BuildKit core engine and we built a system layer on top of that. So an API for orchestrating containers, and then on top of that, an API for writing your own little functions and running them on top of this containerized execution layer. So basically like a standalone, repeatable, ephemeral function system, right? On top of which you can compose workflows. We use that to help medium to large platform teams make their CI/CD and software delivery workflows more repeatable and also more portable, so you can run your CI locally, for example, and then run it again on the CI server, and the same thing happens. All sorts of problems you can solve with that. Anyway, so that's what we're building. And then our open source community comes back and says, hey, this DAG engine made of functions that you can compose on top of this containerized execution layer. I should probably give a demo of that, but I'll get to that. There's this thing called agents now, and we've been experimenting with embedding little agentic functions inside Dagger workflows made of functions. So you're composing these functions passing objects to other functions. You're building this DAG, and some of the functions you're calling are just regular deterministic software, and others actually instantiate an LLM, and they do crazy stuff, but in the sandbox that is the function. And so this is our open source community on the Dagger Discord, just starting to experiment with that and sneaking agents into their CI/CD, basically. And it turns out there's a lot of cool, fun things you can do. And so we've been experimenting with our community around that for a few months now. And eventually, two things happened. More people started asking, hey, could I love this idea of taking these functions and giving them as tools to the LLM, but I already have this other LLM over there in my own app. You know, I'm using Cursor, I'm using Goose, I'm using, Cloud Desktop, whatever. There's this new thing called MCP. Any chance you could expose this cool function composition system over MCP, since you already did the work to bind these functions to via tool calling, right? And so we said, sure. And then we set out to do it. And we've made some progress. And also we ran into some hard questions around the role of MCP and what the spec can do, what the spec can do in theory, and what it can do in practice with the clients we have. So anyway, that's my intro. I guess slides would have been better. Use your listening skills. Let me just give you a quick demo. So this is the Dagger interactive shell. It's just a little client to interact with the underlying engine. Picture an API that you can hit that's language agnostic, right? You can call and chain functions. There's this command line interface, and then there's SDKs. You can do it in TypeScript, Python, Go, Java. Then there's a community of building more SDKs, but it's the same API. And here, just for fun, we use the bash syntax. So you type a command like container, and it gives you container, right? Notice this weird thing, that's an ID, because this is a function that returns an object. It's not a function that just prints text and then it leaves you to figure out what to do with the text. It gives you a reference to an object. What can you do with this object? Well, you can chain more function calls, right? For example, here, if I'm not sure what to call, I can tab complete, because it's all a nice clean API under the hood. But this is a primitive object. It's a container, as in, Docker container. So picture anything you could do in a Docker file, except it's available. You can do it dynamically as functions. So I'm going to say, from Alpine. Now it's executing that second function over Wi-Fi. Actually, it should be doing this over whoop. Okay, I don't know what that is, sorry. I should add that I'm doing this over, just in case, because I've been to conferences before, this is actually connecting to a remote Dagger engine that is at my house, which is a 10-minute bus ride this way. So it should be, let's try again. Okay, now I got a different container object, and I can keep chaining stuff. For example, I can say, hey, give me a file, add a file to this container called hi, that says hi MCP devs. Okay, and it's chaining them. Notice how it's fast because everything's cached by default. That's the nice thing with DAGs. If each operation in the DAG has content addressed inputs, content addressed outputs, you snapshot everything along the way, and everything is nicely immutable, then you get free caching everywhere. And it turns out all of this works perfectly with LLMs, because LLMs actually work that way. You're building the LLM context one message at a time, and the LLM context is immutable, right? You're just adding stuff to it. So this is basically an execution engine that works the way LLMs work. So here I can say, oh, give me a terminal to that container, and boom, I'm in that container. It's an ephemeral container. Oh, here's my file. Ooh, that's slow Wi-Fi. That's my file. Okay, I exited my terminal. The container is gone. It's ephemeral. It's in my little namespace. It's not sitting around on the Docker engine on my machine, polluting, the session of whatever other tool is working with containers. You see what I'm saying? There's a problem, I think, for LLMs in general, whether it's over MCP or not. If you want to if the LLM needs to interact with its environment, it needs to actually run software, do things, it's going to need good sandboxing. And a container is a good sandbox, but it depends how you orchestrate that container really matters. If you get a container, but the container is running on this shared system service, and you have maybe 100 parallel LLM sessions, why not? And they're messing around with containers. Just having containers on its own is not enough. The namespace of the containers has to be cleanly namespaced. There's got to be no exception to the sandboxing. So basically, we built all that, and then again, people were like, "Can I do that with the LM?" And we said, "Yeah, sure." So we added this thing that we called prompt mode in our shell. So if I press, see, it says, what's that called? The chevron. So if I press the chevron, it's going to look for my LLM configuration, and now I'm in prompt mode. So I can say, "Hi, you there?" Okay, so Cloud Code, Codex style, except it's plugged into this API. So I can have the LLM use this sandboxed API and, can you build me a container with everything I need to develop in Go? Also, find the source code of Dagger on GitHub and copy it in there. And so now, this is where the auto tool map, the tool binding takes place. No matter what's available over the Dagger API, all these functions I talked about, they're automatically exposed to the LLM as tool calls. This is where the composition problem appears, and this is the conversation topic number 1, calling for conversation. Whether it's raw tool calling, straight to the LLM endpoint, or over MCP, which is just an indirection to do that with a nice decoupling, getting an ecosystem of tools, blah, blah, blah. It's the same stuff under the hood, right? It's tool calling. I know there's not just tool calling in MCP, but it's built on tool calling, right? The problem is these tools are in a namespace that is flat. The LLM is given a list of tools and is one namespace. When you have objects, oh, by the way, it's done. Oh, I forgot to show this. We have tracing built in. So everything that's happening, that whole interaction is traced, and you can browse it here. So you can see, hey, can you build me a container, blah, blah, blah. It's thinking, and you can see what it's calling. You can see it inspecting the Dagger API. Okay, I'm going to need container stuff, Git stuff. Okay, let me get this URL. Okay, let me use these calls. Container from, that's the same stuff I typed before. Now the LLM is doing it. So you can see it actually do stuff. And here, these are all pretty simple calls, but here you can see, for example, it's polling, and you can see exactly the trace. Okay, what exactly did it pull? This is the exact image it pulled. This is how long it took. This is whether it was cached, et cetera. When you give it more complicated things to do, like a whole end-to-end test, you can have hundreds of nested spans here. And so when you ask an agent to do something very complicated and it says, I did it really do it? No way to know for sure. Go look at the trace. Anyway, the problem is, in order to use the Dagger API, it has to juggle these objects. I call container from, I get a container object. Now I want to call, pass that object to another function call, right? It's like object-oriented programming. That doesn't fit in MCP directly. So what we had to do is figure out a way to make it fit. And that's where you see these weird calls like select methods, list methods. That is basically us adding a layer of indirection on top of raw MCP so that the model can be made aware of the fact that it's not just one bag of tools, it's a list of objects, and each object has its own tools. Getting the LLM to figure that out has been a challenge, but now they're smart enough that they can figure it out. And anyway, I'm almost out of time, so I'll leave it at that. The last thing I wanted to show, because this is an MCP conference, is this exact same thing over MCP. And the way we do that here, we use Goose a lot. Props to the Goose team, by the way. Really nice open source MCP compatible client. This is pre-configured with Dagger. This is a hidden command at Dagger MCP. Everything I showed exposed over MCP. Not in the docs, because it's not finished, but it does work. And we have a whole eval rig to figure out what's the best strategy for mapping basically like a 3D object world to a 2D flat tool calling world. That's the challenge in a nutshell. The reward is composition. The models are really smart, and they can juggle a lot of objects and do a lot of amazing things with not a lot of different object types. But it's worth the effort. So anyway, if you're interested in that topic of object composition, here I could say the same thing, I guess. I would have to say use Dagger to build me a container that has what I need to dev in Go. And then normally, you see the list methods, this. What's cool is that even though it's over a third-party client, I can still go to my little tracing thing here in Dagger Cloud By the way, all these things we run in CI also. So on the left here, that's actually our production CI. You can see like the same engine running these CI workflows, and on the right, that's the team running random dev workflows, and that's me right here. That's other people from the team. And you can see now I'm calling Dagger MCP. And in here, you can see I'm tracing what Goose is asking Dagger to do via MCP, right? So here you can see, okay, I need a container from, container this, container that. And that's it. The last topic I want to introduce, I won't be able to demo because I'm out of time, but I showed an LLM orchestrating the Dagger's core API via this object composition system, but you can extend the Dagger API with your own custom types using Go, TypeScript, all these SDKs I mentioned. So basically, I think Darren called this out. He was tweeting at me like, you should pivot to being an MCP framework because Dagger functions are really nice and simple. You write 10 lines, and then through this, they're now available to orchestrate over MCP. So composition, object composition over MCP, how to make it work well, and I guess evals that include MCP. Those are the two topics that I wanted to bring up. Thank you for your time, and thanks for organizing this.